Hi everyone, so today we will be talking about a math question from Math Olympiad. So here is the question. So x equals to this thing over here, and then the question is asking for what the value of 1 plus 1 over x to the power of 30 is. Okay. So, though I said that this is a question from Math Olympiad, but it is actually not that hard. So, it's just basically high school level knowledge. And so, let's just get started. So, let's first rewrite this entire thing in a simpler form. So, we can write this as 1 plus 2 to the power of 1/5 plus 4 to the power of 1/5 plus 8 to the power of 1/5 and plus 16 to the power of 1/5. Okay, so now it looks much better, and then because we know that 1 equals to 2 to the power of 0, and 2 is just 2 to the power of 1, and 4 equals to 2 to the power of 2, and 8 is 2 cubed, and so on and so forth. So let's just rewrite all of those as the power of 2. So alright. Right. And then, according to the exponential law that we've learned in grade 9, so we can actually switch the power inside and outside bracket. So let's do that. Okay. So now we might notice that this is basically a geometric sequence with a common ratio of 2 to the power of 1/5. So some of you guys might not know what a geometric sequence is, but let me just introduce it. So geometric sequence is a sequence of numbers with a common ratio. So what I mean by that is so for example, there is a sequence D, T is terms 2, 4, 8, 16, 32, and 64. So what's special about this sequence is this term is 2 to the power of 1 and 4 to the power of 2, and this is 2 cubed, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. So now I'm gonna introduce a formula for all of those geometric series, which is Sn equals to A1 times 1 minus r to the power of n over 1 minus r, with r equals to the common ratio that this sequence has. So for example, let's just use a previous example. So if we want to find the sum of each term in this series, in this sequence, then we can just use this formula like this. So A1 is the first term. So the first term I have is 2. So 1 minus r. R is the common ratio, which is 2 in this case, and n. So we have 6 terms, 2 to the power of 6. And then over 1 minus r. So r is the common ratio. So this is here. And then we just calculate this. This equals to 2 times 1 minus 64 over -1. which should be 2 times 63, which is finally 126. And you can check it by using a calculator to do the addition again by adding those numbers up by hand. But I mean, like, for this sequence, because like it doesn't have all of those like really hard to calculate numbers or like a really long sequence, but like some sequences like do have a large amount of numbers, which is like harder to calculate, besides using like the formula that we have right now. But when it turns to this sequence over here, that's a little bit tough because we don't have all of those rational numbers, as you guys might tell. So the easiest way, I guess, to solve this question or rewrite this sequence or calculate the sum of this sequence is just using the formula. So let's do that right now. Just rewrite the formula. Alright. So in this case, A1 is 2 to the power of 1/5 times, this A1 in this case is just 1 because that's 2 to the power of 0. So 1 times 1 minus the common ratio, which is 2 to the power of 1/5, over the number of the last term that we want to find, which is 5 in this case. And then it's 1 minus r. R is the common ratio, so that's 2 to the power of 1/5. So here it is just 2, right? So which is equals to 1 minus 2 over 1 minus 2 to the power of 1/5. Alright, so let's get back to this part. So 1 plus 1 over x to the power of 30. Now this just equals to 1 plus, what's this? 1 over this thing here to the power of 30. And we all know that if there's a 1 over a fraction, then we basically just need to flip the fraction, because that's like much simpler than like we were actually doing the division, because that's might be really complicated, like if we're not familiar with all of those fraction calculations. So like let's just do that. So this just equals to 1 plus, so here is just -1, and then it just equals to 1 plus -1 plus -1 minus 2, and here's plus 2 to the power of 1/5 to the power of 30. So now we can just expand the bracket. So this equals to 1 plus -1, which is just 1 minus 1 plus 2 to the power of 1/5 to the power of 30. And we can just basically eliminate 1 and -1. So what's all left is just 1 to the power of 1/5 to the power of 30. And according to the exponential law again, this equals to 2 to the power of 6, which is 64, and question solved.